So this is the second part of assignment number 3, and it has to do with half-lives. This is the last question. Suppose germ X has a half-life of 8 hours in a person's bloodstream. If no more will be produced, let's say they take an antibiotic that stops the reproduction of these germ cells, we're supposed to write an equation for the number of germ cells left if you began with 100,000 cells in your body. So let's just say we're going to start with 0 intervals, 0 hours. You just took the antibiotic or whatever it is to get treatment. There are 100,000 cells of this germ in your body that's causing you to be sick. So after 1 hour, that's one interval of 8 hours. Now you're going to be down to 50,000. After 2 hours, which is 16, or after 2 intervals, which is 16 hours, you're now down to 25 of these cells in your body. And after 3, we can go one more. That would be 24 hours later. You're down to 12,500 of these cells. And so how do we take that information and write an equation for it? Well, it's going to look something like this. We know it's going to be y equals the beginning amount is 100,000 of these cells. The growth factor, because it's a half-life, the growth factor that we're going to use is a half. And we're going to raise it to a certain power. But we want the x to represent hours, not necessarily intervals. And so, for example, the first interval, if this is 1, would actually represent 8 hours later. If we raise this to the first power, that's going to represent 8 hours. And so suppose that I want to figure out what is going to be left, let's say after 10 hours, which is somewhere between 8 and 16. Well, that's going to be somewhere between 1 and 2 intervals. And what we're going to do then is raise it to the 10 over, that's 10, the 10 over 8th power. Because we're taking each of the intervals and dividing it by 8. Like, for example, if we wanted 16 hours, we're going to raise it to the second power, because 16 over 8 is 2. If I wanted to figure out after 24 hours, well, that's going to be, I want to raise it to the third power. That represents 24 hours. But what I'm going to do is take 24 divided by 8. And so the exponent is always going to be the number of hours that we want divided by the actual interval, which in this case is 8 hours. And so I could use this equation then to figure out what it's going to be like in 10 hours. If I wanted to find out how many of those cells are going to be left after 30 hours, well, it's going to be 100,000 times 1/2 to the 30 over 8 power. And so the general equation just simply looks like this. Your beginning amount, which is B, or is A, let me erase that. The beginning amount is A. Your beginning amount is A times the growth factor, which is B. And, well, maybe I should be more specific. It's A. If it's a half-life, it's to the 1/2 power. And it's always X over whatever the interval is. I'm just going to use an I for interval. And in this case, the interval is 8 hours. And so this is the general equation that we would use for half-lives. So there's a couple examples like this on our homework. Hopefully this will help with that. And if not, we can go over it tomorrow in class. Good luck with your homework assignment, and we will see you tomorrow.